Hello friends. So in last lecture we discussed about the membrane electrode or ion selective electrodes, and we discussed that two words are very important while we are going to learn this membrane electrode or ion selective electrode, that are membrane potential and ion selective electrode. So what is membrane potential? A potential which is developed across the conductive membrane whose opposite sides are in contact with the solution of different composition, but the condition is that the elements are the same. And what is meant by the ion selective electrodes? So the an electrode which is the in which the membrane potential is based on the concentration of specific ion in the solution. So and then we learn about the formation of this ion selective electrodes, and how can we find out the potential of membrane through the symmetric potential, asymmetric potential, uh, and about the asymmetric potential. What is mean by asymmetric potential? So the again, what is mean by the asymmetric potential? The asymmetric potential is the small potential which is developed across the membrane that presents even when the solutions of both sides of the membrane are identical. For example, there are two solution of ion, Fe plus 2 and Fe plus 3, and one side there is Fe plus 2 ion and another side is there is Fe plus 3 ion. So and the potential is developed, that is called the asymmetric potential. And then we go through that, how can we find out the potential of cell through this asymmetric potential. So this is about the last lecture now, and this is the final formula which we get to find out the potential of any kind of ion selective electrodes. Now today we are going to learn some specific ion selective electrode. First is glass electrode. Now what is glass electrode? Maybe you learn about something about the pH measurement. In the lab you use pH meter instrument, and you also maybe learn about the electrode which is used in the pH meter. So this is the same electrode which we use in pH meter. It is a glass electrode. Basically this glass electrode is used for the determination of pH, but there are also some another application of this also, that we will discuss later on. So see, the formation of glass, this is the common structure, or we can say that the pictorial form of the glass electrode. It contains the internal reference electrode. This is the reference electrode, which is made by the AgCl, or we can say that the silver reference electrode, and it is immersed into some acidic solution, which is the inert filling solution, and it is in the glass bulb or glass tube over there. So this is this is your glass membrane which hold the acidic solution, which concentration is known, and one standard electrode immersed into that acidic solution. So this is just a formation of the glass electrode. Now it can be represented by this shorthand notation. As we know that every time we have to put the reference electrode on the anodic side. So this is our the reference electrode. On the other hand, this is the main shorthand notation of this glass electrode, which contain the acidic solution, which is the unknown, then glass membrane, then this internal solution, and this internal reference electrode. Now this is also called a bulb, glass bulb. This portion it is also called a glass bulb. So whenever we are going to measure the pH of any solution, we have to just immerse this glass bulb into the sample solution. Now see the potential of glass membrane, we already discussed in the previous lecture. We can found from this formula. It is E cell is equal to K plus 2.303 RT upon F log activity of hydronium ion. And we all know that what is the K? K is the constant that includes the potential of two reference electrodes, the potential of liquid junction, potential of glass membrane due to the internal solution. So the only unknown thing is the activity or the concentration of external solution, which we have to find through this potential. And the K, that's why the K is called gives the asymmetric potential. Now see, this asymmetric potential is depend on the following factors, such as the composition of membrane, because there are several composition to make this glass electrode, which has some sodium portion of sodium silicate, lithium, etc. Second, strains within the membrane. Third, mechanical or chemical attack on the glass, or we can say that the external surface, and the degree of the hydration of the membrane, and its slow change with the time. All the process are very slow. It will need some time to occur. So especially if the membrane is allowed to dry. So we can say that if we put our membrane or glass electrode into the dry condition, this factors are influencing the potential, asymmetric potential. And due to this reason, whenever we are going to use the glass electrode, we have to calibrate at least one. Without the calibration, we are not able to use glass electrode directly. So that's why we every day calibrate the pH electrode. Maybe this is very important question for the interview purpose. Whenever you are sitting into the in front of the interviewer, and then he asks you that why we calibrate the pH meter every day. So this is the reason, because when if we don't calibrate the pH meter, one of the factor can influence on our result. Okay, so that's why we calibrate the pH meter, the glass electrode of the pH meter every day. So now see, uh, pH is equal to the activity of H plus ion. So if we uh, put pH over here in place of the activity of H plus ion, we can write down the same formula in this way. Okay, and if we rearrange it, pH, we can find out the pH of our unknown solution through this formula. Now see, how can we find out the pH? We just immerse our probe into the sample solution. We get some potential on the small LED of which is on the instrument, and we have to just put the value of that potential over here. K we know the value of the K. All other things are also constant, so we can find out the pH. Now the K, which is unknown over here, we can find out this formula. E cell is equal plus 0.203 RT upon F of the pH standard. Now, which pH standard we use over here? So there are some buffer solutions. We know that we can calibrate the pH meter by the buffer solution of 4 pH and 9 pH and 7 pH. So the same pH buffer we can use over here. We can put the value either 4.2 or 7 or 9 over here, and we can calculate the K. This value we have to put over here. So ultimately, if you put the value of K into this formula, we can find out the final formula, which gives pH of unknown is equal to pH standard plus potential of standard cell minus potential of unknown cell 20303 RT upon F. So this is the final formula to calculate the pH of unknown solution, and based on this formula, our pH meter is work. So you have to remember this formula. In the lab exam also, some examiner will ask the question that write down the formula on which your pH meter operate. So this is the formula on which our pH meter is working. Okay, now another thing is combined pH electrode. Now see, this is just the inert part of the glass electrode, but this glass electrode is covered by another tube and combined with the external solution also. That's why it is called a combined pH electrode. It consists of tube. Within a tube there is a inner one housing of the pH indicator electrode and other outer one housing of the reference electrode. Now see, if you see the diagram, this is our bulb, which we already glass bulb, which we already discussed. It contains a internal reference electrode. It contains a acidic solution, okay, which is connected by some electrode terminal. Now this another tube contains a indicator electrode, this one. Then KCl solution, which is connected to the salt bridge, and this portion will be remain blank. Our sample solution we put over here. This is the portion when we put our sample. Now what is the working mechanism of this glass membrane electrode? How this glass membrane electrode give result or give the potential? So let's discuss it, and it is a very important topic for your exam also, and for your future research work also. If you go into the research work, or if you go into any QC lab, this mechanism will be very helpful in to develop some pH meter based development method development. So now see, the pH of the glass electrode depend on the ion exchange on the surface of the hydrated layer. Now see, basically glass is made by the sodium silicate. Now what is sodium silicate? It is the sodium silicate is the composition of sodium oxide and silicon oxide. So basically our glass is made by sodium oxide and silicon oxide. Okay, and it is in this kind of form. So when we submerge this glass electrode into the water, initially we have to hydrate it. So if we put into the water, it will react with the H molecule or H ion of the water, and the sodium and H plus ion exchange with each other, and this structure is formed, or we can say that this layer structure is formed on the outer side of the glass bulb, where we can say that H plus is our counter, and which will be movable, which will be free, right? Like the SiO sides are the fixed, but the protons are free to move and exchange with the other ion also. Okay, so the potential of membranes, that's why the potential of this membrane is dependent on the H plus ion, because this is the only ion which is movable after this reaction. So the potential of the membrane is dependent on the hydrogen ion activity only. Now the hydrogen ion activity is depend on the boundary potential and the diffusion potential of glass membrane. Now what is mean by this boundary potential and diffusion potential? Let's discuss it. Okay. What is mean by the boundary potential? So see, boundary potential, it will be occurred on the outer side of the glass bulb or the glass membrane. That is it is the interface between the hydrated gel, which is made on the glass bulb, and the external solution. External solution, it is our sample solution. We have to remember it. What is the external solution over here? It is our sample solution. In short, if we submerge our pH electrode into the sample solution, on the outer surface there is one hydrated gel. What is our hydrated gel? Our hydrated gel is this SiOH. Okay, and the external solution. So if these two create some kind of potential, that is called boundary potential. If you have any doubt, please write down in the comment. I will give answer promptly. So when the electrode is dipped into the aqueous solution, a boundary potential is built up, which is determined by the activity of hydronium ion. Now see, here only one ion is important, which is the hydrogen ion. How whole mechanism of this glass electrode, is based on the activity of hydrogen ion. Okay, so now see what happened. There are two kinds of hydrogen ions are take place. One is the internal side, and other is the external solution. So the activity of hydrogen ion is the external solution, and the activity of hydrogen ion on the surface gel we have to remember. And what happened? It follows the Le-Chatelier law. Now, what is mean by Le-Chatelier law? You learn into the 12th or 11th standard. Le-Chatelier law. It told that law told that when there are two solutions are in contact with each other, and they are same species, like as on the both the species are hydrogen ion here same. So if there is the same species but the different concentration, the migration of ion move from the higher side to lower side. So same thing happen here when this two different concentration containing hydrogen ions are in contact with each other. The ions will tend to migrate towards the lesser activity ion. For example, if our solution is more acidic, it means it has a more number of proton. Okay, if it is acidic, then it has more number of hydrogen ion, it has a more number of proton. And if we so these protons which have a higher population, they are migrate towards the gel side, towards the surface side. Sorry. Oh, just a minute. Just a minute. Now here it is. For example, if we take a sample solution which is more acidic again, if it is acidic, it has a more number of proton in it, more number of hydrogen ion in it. So now if there's a more number of hydrogen ion into our sample solution, so the hydrogen ion which is in our sample solution will be migrate towards a glass surface. Okay. uh, Towards the glass surface, or we can say the surface of the gel. It built a positive charge. It is a hydrogen ion. Hydrogen ion is a positive charge, so it builds more number of positive charge on the glass surface. Hence, the potential of the electrode is increased. See, if there is a more number of hydrogen ion, potential of the electrode is increased. Now, why this potential is increases? Already we learned this formula in the last lecture. Potential of the cell is equal to K plus 2.303 RT upon F log activity of H plus ion. Now, if we see that only variable thing is activity of H plus ion and E cell, and both are proportional with each other. Okay, so here if the potential, or we can say that the activity of H plus ion is increases, okay, potential is also increases. Now if we convert this log activity of H plus ion into the pH form, we can rewrite this formula into this manner: E cell is equal to K minus 2.303 RT upon F into pH of unknown. Now it means, again, now E cell is inverse proportional with the pH. It means if the potential is high, pH is low. If the potential is high, pH is low. What over here? In this case, if we consider the activity of H plus ion, and both are proportional with each other, but if we convert this activity of H plus ion into the pH, it will be inverse proportional with each other. It is just mathematical terminology. Okay, so we can say that if the potential of our system pH meter is high, the pH of the solution is low, because here the negative charge, that's why both are inverse proportional with each other. Okay, again we have to rearrange this formula, and we can find out pH of unknown is equal to K minus E cell 2.303 RD upon F. So by this we can find out if we can get the more potential. If we put the value of that potential over here, K is already known. Okay, we can find out the pH which is less. Okay, in the inverse system, if the potential of system, if the potential is less, so the value of the system is less and the pH will be more. So it will be alkaline solution. So this is all about the boundary potential. Again, we have to revise it. What is boundary potential? Where it took place? So boundary potential take place at the interface between the hydrated gel layer and the external solution. Now, when the electrode is dipped into the aqueous solution, a boundary potential build up, with determined by the activity of hydrogen ion of the external solution and the activity of hydrogen ion on the surface of gel. Here just we have to consider the activity of the hydrogen ions, and it follows the Le Satirial principle. Again, I told it follows the Le Satirial principle. Why Le Satirial principle? Because it tend to migrate direction on the laser activity. Okay, so whenever the activity of H plus ion is low, H plus ion, remaining H plus ion move toward that side. For example, if we take the acidic solution as our sample solution, so alwaysly in the acidic solution, protons are more. Okay, so these protons migrate towards the surface gel, because on the surface gel, the amount of H plus ion is very less. Now, if the acidic proton migrate towards the surface gel, it build up the positive charge, it increase the potential, and if it is increase the potential, then we have to consider this formula. Okay, then we have to convert this activity of H plus ion into the pH, and we find out if the potential of cell is increases, same the pH is decreases. So this is the way we have to find out the pH. If we just consider the boundary potential, again we only discuss over here boundary potential. The remaining one is the diffusion potential. Now what is mean by diffusion potential? So here it is. The diffusion potential is depend on the activity of proton in the inner part of the gel layer, a part of the gel layer diffuse toward the dry membrane. So now see, it is the completely inner side, standard side. In the inner side, we know the activity of H plus ion. Okay, when our electrode is dry, it is not hydrated. So this H plus ion tend to dehydrate, tend to hydrate that dry membrane. Okay, and that's why H plus ion from the inert part will be diffused on the dry membrane, which consists the sodium silicate. Our dry membrane is made by the glass. Glass contains the sodium silicate. So it means the tendency of the sodium ion in the dry membrane is diffused to hydrated layer. We can indirectly we can say that sodium ion of the glass replaced by the H plus ion, which is in the inner solution. See, boundary potential take place on the outer side of the glass electrode. Diffusion potential take place into the inner side of the glass membrane. This is the major difference between these two potential. But at the same time, similar phenomena by the boundary potential take place on the same membrane, and that's why the effect of this diffusion potential will be nullified. It will almost zero or remain very, very low. That's why we are not consider this potential to measure the pH of any solution. Hence, the potential of membrane is determined by largely by the boundary potential. Again, these two potential are very, very important while we are going to explain the mechanism. You have to remember three things in the mechanism. First thing is that when we put our glass electrode, which is made by the sodium silicate or sodium oxide and silicon oxide, into the water, when we are going to hydrate it, at that time the sodiums into the sodium silicate can exchange by the hydronium ion or proton. Okay, so it forms some like salicylic acid. This is the formula of salicylic acid. Okay, and in this case, SiO, it is a fixed site, but the H plus ion is a movable. It can be migrated or it can be exchanged with the other ions. That's why the potential of this membrane is depend on the hydrogen ion activity only. Okay, now this is the first thing. Now, second thing is that hydrogen ion activity is depend on the two kind of potential. One is boundary potential and another is diffusion potential. Now, what is boundary potential? So, boundary potential is the potential which take place on the outer side of the glass membrane, which can take place in the interface between the hydrated gel layer and external solution. What is external solution? It is our sample solution also. Sample solution. So when the electrode is dipped in the aqueous solution, a boundary potential is built up, which is determined by the activity of H plus ion of the external solution, which is our sample solution, and the surface of the gel. Now, when they are in contact with each other, they would like to reach at the equilibrium, and at that time they follow the Le Chatelier law. That law state that the migration of the ions from higher side to lower side. So the migration of the direction is laser activity side. So for example, so to prove this, we have to take one example. If we take a acidic solution which has a more number of hydrogen ion in it, so these hydrogen ion are migrate towards the surface side, surface gel side, and due to that they build the positive charge on it. Hence, the potential of the electrode is increases. It indicates by the following formula, which we already discussed in the last lecture, how this formula is derived. we have to convert this log of activity of H plus ion into the pH. We know that what is the formula of pH? pH is equal to minus log activity of H plus ion. Just we put over here. So the sign is changed. So this is the final formula of the potential based on the pH. Now we can see that the both are inverse proportional with each other. Why? Because minus sign over here. So if we convert or rearrange this formula into the, and we make a pH as a numerator, we can find out the pH is equal to K minus activity of K minus the potential of cell upon 2.303 RT upon F. Now again, from this formula we can say that pH is inverse proportional with the potential. So if the potential is high, pH will be low. So this is about the boundary potential. Now what is mean by the diffusion potential? So diffusion potential, it is the exact opposite phenomena of the boundary potential. It took place into the inner surface of the glass bulb, okay, where the inner solution, which is also acidic solution, will be going to hydrated the membrane which contain sodium silicate. So at that time again sodium will be migrated, or we can say that exchange through that solution. But at that same time, same kind of phenomena which is called the boundary potential take place on the outer side, and this phenomena are more strong than the internal phenomena. Okay, that's why the effect of this diffusion potential will be nullified, and hence we can only consider the boundary potential in place of diffusion potential when we are going to measure the pH. So this is all about the mechanism of glass electrode while it is going to the pH measurement. Now, during this measurement, some kind of errors are take place. There are two kind of error: alkaline error and acidic error. Just we have to discuss it and finish our lecture. Now, what is alkaline error? So such error, it is due to the capability of the membrane for the responding the other cations beside the hydrogen ion. Now see, in simple word, we can say that in place of hydronium ion or H plus ion, if some other cations like as potassium ion or sodium ions are influenced on the glass membrane, this kind of error took place. When the hydrogen ion activity becomes, and when this kind of situation take place, so always when the activity of H plus ion is very less, our solution is highly basic, in which the population of H plus ion is very low. At that time, this H plus ion compete in the potential determination mechanism. Which ions are compete? This potassium or sodium, etc. Now why I specifically told potassium and sodium? Because we know that what is the internal solution in it? It's a KCl. Okay, so there is a potassium ion. Okay, then why I told sodium ion? Because the glass is made by the sodium silicate. That's why these two ions are influenced in this mechanism, in this error. So although the hydrated gel layer prefers the protons, it need proton. Okay, they love proton, but they don't get it. In place of proton, they get sodium ions and potassium ion, which can exchange through the proton layer when the hydrogen ion activity is very slow. So in place of, we can say that proton, they get potassium and sodium ion. But we can say that potential is depend on the, and due to this, the potential of this electrode is depend on the sodium ion, if there is a sodium in more population in it. Okay, sodium internal and sodium out external. And that's why this became, now this electrode became a sodium ion electrode, not a hydrogen ion electrode, not a pH electrode. Now it is turned into the sodium ion electrode. Okay, because it prefers, or it get more number of sodium ion in place of hydrogen ion. Now see, this error is negligible when the pH is less than 9, but when the pH is more than 9, or we can say that highly alkaline solutions are there where the H plus ion concentration is very less, at that time this kind of error took place. So the electrode responds other ions such as potassium and sodium, and the electrode is the it is a machine. It is not know whether there is a potassium ion or sodium ions or hydrogen ion. It just see the more hydrogen ions, but in place of hydrogen ion, it get sodium and potassium. So that's why the pH reading will be go down. It get a false reading. It will be get a false reading. So potential will be high, and that's why pH will be low. We already discussed into the boundary potential. Both are inverse proportional with each other. So in place of hydrogen ion, they get sodium and potassium, but it need only the positive ion. This sodium and potassium ion also occurs the we can say that positive charge also contains the positive charge surrounding the glass membrane. So that glass membrane doesn't know that this positive charge is due to the hydrogen ions or sodium or potassium ion. It just consider the increasing of the positive ion, and that's why its potential became high. But originally that potential which is high, it is due to the sodium and potassium ion, not because of hydrogen ion. So we can get a false reading, and we can get a false reading. This is called a alkali error. So how can we overcome by this error? So by the changing the composition of glass. I already told you the glass is made by the sodium silicate, which contains sodium ion and silicate ion in it. Now here only sodium ion interference in this mechanism, not a silicate ion. So in place of this sodium oxide, if we use lithium oxide, okay, we can overcome this problem. And if we use a lithium oxide in place of sodium oxide, that is called a lithium glass electrode, not called a sodium glass electrode, and that it will be used to full range of the pH between 0 to 14. So this is all about the alkaline error. Now second is the acidic error. When the very low pH value, when we take a very acidic, highly acidic solution as a sample. So when we submerge our electrode into the highly acidic solution, our glass membrane absorb the molecules. Why? Again, exchange of sodium and hydronium ion. There are more number of hydrogen ions in our sample solution, so they are easily exchange the sodium ions. Okay, so and we can say it is absorb acidic molecules. So this absorption decrease the activity of H plus ion into our sample solution. This absorption decrease the activity of hydrogen ion into our sample solution. So when we measure the pH, we get a false result. Lower potential will be occurred over here, and if the potential is low, pH will be high. The potential is low, pH will be high, because both are inverse proportional with each other. So that is called a acidic error. So this pH measurement therefore shows the higher pH value than the actual pH value, and this is called a acidic error. And this kind of error will be took place when we use a water or aqueous solution with a high concentration of dissolved salts, or some non-aqueous solution. If we mix with the aqueous solution like as ethanol, if we take a mixture of ethanol and water in some specific ratio and put the electrode in it, we can get a false reading. It would be created due to the acidic error. So we have to take some precaution if we want to avoid this error. And basically acidic error are very negligible against the alkaline error, so there are not any specific mechanism for it. So this is all about for the today's lecture. Again, just we have to revise it. Today's theory are very important. The theory of glass electrode is very important. This is the formation of glass electrode, thus the inner formation of the glass electrode. It is made by one glass, which is made by the sodium silicate. This glass tube or glass bulb is filled by the internal filling solution, which is KCl, or which is the acidic solution, HCl, which is the acidic solution, and it contains one electrode. It is a reference electrode, silver reference electrode. This is the combined glass electrode with the sample solutions also. This is the working mechanism. We have to remember three things in the working mechanism: exchange of sodium ion with the proton, and only the proton ion is responsible for the potential change. Then potential activity of this H plus ion is dependent on the boundary potential and the diffusion potential, and the role of boundary potential is very big than the diffusion potential. Okay. Now, what is the boundary potential? So it occurs on the outer side of the glass membrane. Diffusion potential will be take place into the internal side of the glass membrane, and there are some errors while we are going to take the potential measurement. Alkaline error would be take place when we use a highly alkaline solution less more than 9 pH, and the acidic error uh, would be take place when we take a highly acidic solution for the measurement where the pH is less than 1. So this is all about for the today's lecture. If you have any doubt, if you have any query, you can contact me. You can write down your question into comments also. Thank you so much.